The final addition pathway to polymers that we're going to talk about involves radicals. And this will look strangely like the other examples that we've already seen. So again, we're going to draw 3 monomers. I'm just going to put R groups on here. We don't need our R groups, the groups on the alkene, to have a big electronic bias. We don't need to have electron withdrawing groups, stable anions. We don't need electron donating groups, stable cations. We simply, well, we don't have to have anything on there, but typically you have something on here. So we're going to have some kind of initiator. I'm just going to write it as I. Some source of radicals. So what's going to happen is this radical is going to react with one of our monomers, one of our alkene monomers. And we will generate a new radical. And of course, that radical is going to do the same thing that the initiator radical did. It's going to react with an alkene and do a radical addition to that alkene to make a new radical, and of course we're just going to do this 1/3 time. Okay, 3rd time's the charm, and we get this new radical. This radical, at some point after doing this 3 times or 503 times, we're going to get a radical on the end, and often what will happen is these radicals will find a hydrogen atom in the mixture somewhere. And so we will get a hydrogen abstraction. And that's what will ultimately kill the reactivity of our radical and quench the reactivity of our radical. So shorthand, we would write, okay, we had an initiator, and that reacts with an alkene, and we get N of these. And how many is N? You know, it just depends on the efficiency of the polymerization. But we string together a whole bunch of monomers, and then somehow that chain gets terminated. So this is how a radical addition polymer is formed. And these are very common. Of course, cationic polymerizations are pretty common, and anionic polymerizations are pretty common. It really depends on what sort of monomer you're trying to put together. But these are all examples of addition polymers.